something called the inverse of a function. The inverse of a function is when you take the domain and you replace it with the range and vice versa. It's denoted with a little -1 up here. It is not an exponent. It is the notation for inverse. And it's such a simple concept. Basically, if I replace the domain with the range and the range with the domain, and I started with this function you see here, then the inverse of this function would be 4, 3, 0, -2, -8, 2, 3, 1, and 4, 8. Now, what that does is it sets up a situation where we can talk about the original function. So looking at the original function, I don't see any repeated input values. So the original function or relation is a function. Yes, it's a function. And its domain is these inputs in blue in order. So -2, 1, 2, 3, and 8. And its range is the blue values, output values in order. So -8, 0, 3, 4. Notice the 4 is repeated here and here. So I don't only write it once. Well, that repeated 4, when it reverses, causes the inverse relation to be a no, right? And the reason is look right here. 4 goes to 3, but 4 goes to 8. So the domain, if I look at the orange one, the domain is -8, 0, 3, and 4, which shows you that these simply switched, right? Those switched. And the range is, sorry about that, I'm just going to fill that back in. And the range is -2, 1, 2, 3, 8. And you can see that those have also switched. The domain and range have switched, and that is the definition of an inverse. Sounds like a weird concept, but it's very easy. So to look at that graphically, the graphical definition of an inverse is, again, replacing the domain with the range and vice versa. And it's going to create a reflection over the line y equals x, because when I replace the domain with the range, it actually is saying that y equals x. So let's take a look at how that happens. It's also very straightforward and easy to understand. If I were to take a look at this parabola, we don't need to know how to graph it at this point. We just need to know that it's made up of points. I have a point here at -2, 2, which is its vertex or minimum. I'm going to come up with some other points to help me denote the function, because a graph is simply a list of points that are produced from inputs and outputs. And if they give me the graph, I can easily denote them by just looking at the graph. So -1, 3. What's going to happen if I want to graph the inverse of this graph, and this is a common SAT question, to find the approximation of the inverse, all I have to do is take these points, right? The points are -3, 3, -2, 2, and -1, 3. And all I have to do is just reverse them. So if this is f of x, then the inverse, as we just learned a minute ago with points, the inverse would be f inverse of x, and that would produce the points 3, -3, 2, -2, and 3, -1. I'm going to go graph those. So 3, 3, -3 is here. 2, -2 is here. And 3, -1 is here. And that would produce an inverse of parabola looking like this over in this side. And that parabola would be a reflection of the original over this line. So that line, you can see the perfect reflection. If I looked from this line to that line, I would get that. And again, this one is the original f of x, and the other one is the inverse. Now, one other thing that I think is really valid to look at is this idea. So this thing's domain, right, would be negative infinity to infinity because it goes from left to right the whole time. And this thing's range would be, remember, output 2 to infinity with an inclusive bracket. Well, what's interesting about that is that, again, because the definition is to replace the domain with the range and the range with the domain, if I look at the graph below, and this is my inverse, watch what happens when I try to analyze the domain. The domain of this graph is going to start here at 2, and go to infinity, right? It would be a bracket because it touches 2, and it goes to infinity, which is the exact reverse of there. And then the range of this graph would have arrows on it, so it would go down forever to negative infinity and up forever to infinity, making the range negative infinity to infinity. And so if I take a look at this range, I'm just going to put it in order as the other one is. The range is the domain is the range, and that is the definition of an inverse. Hope you've enjoyed this video about functions, domains, and ranges, and I hope you've learned a lot about how these work.